mishaps. And Happy New Year to everyone. A bit late. First call for the year. First community call for the year. I hope everyone had a good holiday. We have the agenda for today. As you saw, we have the regular update for the section, the activities, etc. And then we have a presentation later at 9 o'clock. Wayne will dial in and give us an update. I think it's going to be an interesting one. So for the sake of time, let's get going here. Let's see. This is the agenda. You saw in the invitation email. So as always, starting with the membership numbers for the year. Let me make, we have, so I can see how many people we have in the call, and if anybody raises their hand. 1 second, let me move this out of the way. Okay, very good. So we closed the year slightly up compared to 2022, which is a positive number, a positive thing. We went from 2,200, let's say, the end of last year to 23 something. So an increase in the order of 5%, 7%, something like that. So it's a good thing. It's a good trend, I should say. And we need to do what we can with the content and the activities, etc., to keep that. Now, the real positive news is the student membership, which is the green line in the bottom. You see that we had something in the order of 20% increase. This is consistent with what we have seen the last few months, which is a good trend, and hopefully we manage to keep that going as well and expand on this, because these students really are the members, the professional members for years to come, hopefully. There is another graph that SP started creating, how many student members are converted to professional members. It was there last month. I didn't see it this time, but it is in that order. 20% basically of the students, of the student members become professional members every year. That's a good trend. Now, just supplementing this view here, the second set of graphs that show the distribution of members geographically by area, and then by service company, by industry, company type, and age. So all in all, I mean, these graphs here, they don't change significantly from meeting to meeting. The biggest section you can tell here is Middle East and North Africa, and that's telling. It has surpassed the Gulf Coast, North America section here. But all in all, there are several sections that have good representation, which is also a good thing. And that says that we need to have program chairs for DSATS in those areas. We have to have every area represented. And we'll come to that in a slide or two when we talk about the elections and the annual meeting. Age distribution, I think, is overall healthy. We have a good size population in the middle, about the same between younger and older people. We just need to focus on the younger people, bring in more young people. So all in all, I think it's a good picture, but we never have doing good enough. We have to do some more to attract more people. So here is the slide for the annual meeting that is coming up very quickly on March 4th. As probably all of you know, that's the annual meeting for DSATS, out of sync with the rest of the technical sections that have their annual meeting at the ATC in October. Since we are so close to drilling, we are having ours at the drilling conference every year. So this year is on Monday before the conference, on March 4 in Galveston. And amongst other things, we have a few positions that we need to fill. We have 3 directors that we have to fill. 2 are the term is expiring, Mori and Pradeep. And the third one, Tony Ping, stepped down because he moved to geothermal, a different position. So we have 3 positions that we need to fill. Those are 5-year terms. Also, Austin is not going to continue as the chair for North America. After the event, he's organizing this event in March, but after that he got a new job and he doesn't have the time really to contribute here. So we need to fill that role. And then the last one is the program chair for Africa, which is vacant right now. We don't have a person there. And as we saw earlier, we have students everywhere. And we need to have those students, we need to be able to represent them and talk to them and engage them, So it's important that we fill these positions. So the way the process works is that there is a nominating committee, a director, and 2 general members that come up with the nominations about now, 45 days before the meeting. And we publish this, and unless there is any objections at the meeting, really we just approve. It's a formality. So we don't have nominations right now. And if anyone would like to nominate someone for these roles, or if they would like to self-nominate, but they will need a secondment for self-nomination. Someone else has to support you as well if you want to come forward and nominate yourself. So in any case, if you want to help participate in this process or get involved, please let me know. And we need really people to participate. That's a sign of a healthy section. That's all I had really in this slide here. If there is any question or anything from anyone, feel free, raise your hand and let me know. So the next topic is the drill robotics competition. This is a student competition that we have for many years now. Fred and Sasi have been leading this. I think I saw Fred's name here on the call.
I just joined, Dimitrios. Sorry, I was running late.
Okay, Sasi, you want to give us a brief update on this?
Actually, Fred, since you wrote it up, I'll let you cover it, man. Give you credit for writing it up.
Fred, go ahead, please.
Enrique is going to become the new webmaster as I step down at the end of the month. And I really want to thank you, Enrique, for your involvement all along as a judge, as a student leader. You've done a great job, so I really appreciate you stepping up. We need sponsors for the year. We haven't had a single sponsor come forward, so we need money to pay for these students to go to Galveston. So please, anybody who's got a few dollars, $500 or more, that'd be enough. David Gibson is still working on his documentary. Haven't heard the latest. I sent him a message yesterday, but haven't heard back. The teams that will be coming to Galveston include the University of Stavanger and Clausthal, Technical University of Clausthal. And Clausthal said they all got their visas yesterday. UIS is still working on theirs, but they should be okay. And been working with them to make arrangements for airfare, for hotel accommodations and stuff like that. SB's given us a booth, so we'll be there and we'll get the last bit of furniture and everything ordered this week. So that's moving pretty well. With respect to this year's competition, we have a few judges. We got room for more. Contact Shashi. Shashi's arranging a kickoff meeting that will start in the next couple of days, next couple of weeks. We've got to read the results of the submittals from this year's team and figure out who makes it to the finals. And because some students had trouble last year interfacing with the North simulator, we want to try to have another webinar set up for them. And I'm planning to go down and meet with LSU end of next week, and hope to see some of you guys in Houston.
Thank you, Fred. Before we continue here, Greg, if you are on the call, can you please start the recording? Also, one more point here on this slide. John McPherson, is trying to see if we can get any interest from the geothermal community on the drill botics to another direction to expand drill botics. And there are some resources out there, funds and technical expertise from the industry as well as from the government, that we're looking to see if we can get any support to keep the competition going and adapt it, to the new challenges, new realities in front of us. So that's in the very early stages. We don't have anything concrete yet, but hopefully we get something there and manage to bring in some funds to keep the competition going. Like Fred said, support and sponsorship is drying out for whatever reason, and this is unfortunate, but this is really the lifeblood of the section, getting these students interested. We don't want this to let this, get phased out. Anyway, so that's all we had on the robotics. The next topic is the DWIS update. So the last month, 6 weeks or so, it has been slow because of the break, etc. But here is what is happening, where we stand. There is a paper that we have submitted. The advisory board of the DWIS, they put together the abstract, if you remember, last fall. Then the complete manuscript. It became a good paper, in my opinion. The objective is to highlight the business case, the business benefits of interoperability, why it makes sense to develop this from an operator's perspective, from a contractor's perspective, from service company perspective, and how do we all work together. I hope that this will become a much talked about paper that will generate more interest going forward. Apart from that, there is a number of initiatives that are going on. SMART initiative, World Data Foundation and others, and we're trying to keep in sync with those and make sure that we don't step on each other and rather complement each other. And from the early discussion so far, the work streams and the work that we need to do and the direction that we're going and input from the advisory board, I think we're going to end up having another workshop sometime this year. It was almost 2 years ago that we had the last one, and we need to kind of realign, I guess, and make sure that we're all on the same page about who does what, in terms, for example, the interfaces, the ADCS, the automated drilling control system. How do we make this in the most sensible way? We'll see. More details will come about this workshop. Now, in the actual work streams themselves, where the discussion stands in each one of them. On the interfaces work stream, Loic has taken over from Mark Carrier. There are four interfaces that have been developed so far for hoist, rotate, flow, downlink. We're trying to, as if some of you know, try to make those general enough that apply to different markets, high end, high volume, etc. The discussion right now is on what we call the tag bottom interface, how to develop, the data transfer, the communication that needs to go from external advisors to the rig about tagging bottom in an optimal way, coordinating the hoisting, the rotation, the flow, etc. How do we do that in a way that makes sense? And every situation is unique. Every rig, every contractor has their own particular ways of doing things. How do we make this broad enough and generic enough that can apply to a broad range of all these scenarios? So it's an interesting discussion, and a lot of questions are coming up in that discussion. That's why the need for a workshop. The other work stream, reference architecture, Clint Chapman stepped aside. He didn't have more time really to contribute, and Arima Ayana Bakam from Neighbors stepped in. Arima had given a webinar in DSATS last year about the smart ROS that Neighbors has, and that was very much aligned, with the work in this work stream. So I contacted him, and I thought it was great that he was interested, and it's excellent, I think, to have someone from a contractor, someone that has a hands-on experience on ADCS development, lead this work stream. So I'm very thankful about this. Then the drilling process protection and the safe operating envelope workstream and the semantics of real-time signals. Eric has been leading both of them, and he thanks. I want to say here publicly a big thank you to Eric for his contribution, and he's continuing this year again, building on the momentum that we had at the demo last September, and he's working closely with 2 ADCS vendors, which is also another very positive sign that we finally get some traction with the people that actually the practitioners that offer these technologies and are working on these technologies. So that's where we stand on DWIS. Despite this last slow month, I think now pace is picking up, and hopefully we're going to have some more good progress for the next call in a couple of months. And as I said, the workshop will have to work on putting this together. All right, so the next topic is the verification and validation work that Rodica is leading. I'm not sure is Rodica on the call here. Maybe she can walk us through the slides here.
Yes, thank you, Dimitrios.
Yeah.
Yes. So similarly to Davis, there was not much work done during the last month due to holidays, but I wanted to give you a short update on the work basically for the last year. So we have an ongoing work on mapping existing definitions for verification and validation for complex automation systems. So what we are trying now is to identify which of these definitions fit the specific needs which are addressed in the drilling domain. So we have large tables that we are building in with the people in the group. We also have been working on mapping different methods that can be used for formal verification of consistency of data and functionalities. Keep in mind that we are talking not about a monolithic architecture for verification and validation. We are talking about a multi-agent type of architecture in the group. And we are also exploring synergies with the work done in complex artificial intelligence systems. So far, we have discussed on different methods. One of those will be presented today by Wayne. We are very happy to have Wayne stepping up. It's STAMP, Systems Theoretic Accident Model and Processes. In the group, we've also discussed on other methods such as validation triangle and other formal model-based assurance cases in Isabel. And the idea is to start disseminating, having a series of presentations on these different methods that we talked in the group. We start today by having Wayne talking about STAMP, and then we will propose more presentations from the group. If you take the next slide, please, Dimitrios.
Yeah.
So the group is very much focused on dissemination with a broader publicum. So we have, as I said, Wayne today, and where we have also been discussing in the group to prepare an abstract to summarize some of the work done in the subcommittee during last year. We have been also held some presentation on the activities of the subcommittee for industry participants and academia at DigiWell's annual seminar in Norway, organized by Norse. And also we had the presentation and a broader forum on artificial intelligence systems in France, organized by the AI Data Robotics Association and European Commission. And there are several people interested in how we plan to do that in drilling, and also they wanted to share some of their expertise from the autonomous systems. Thank you.
Thank you, Rodica. Let's continue then. Got a couple of more slides here. So the last regular topic in the update is upcoming events and activities. So here is what we have so far in the calendar. We have the annual meeting on the 4th, and Austin and John DeWard are working on putting this together. There's only less than 2 months left, really. They're still working, putting together the panel, the committee, etc. Cannot share more details at this point, but please visit the website and register, and there you will see all the latest on that. In terms of webinars, we have 2 spots allocated by ESP, one on March 15. It's a Friday at 9 a.m. There may be a conflict with the advisory board meeting that we have every couple of weeks. I'm not sure if that's one of those Fridays or no. And then the following one is in October, another Friday at 9 a.m. So both those are open for now, and we're exploring, for candidates to give presentations. There is a possibility there at the bottom that Sasi has kindly offered to. He's checking right now, see if that works out. It may fill that first spot, but there are opportunities for anyone really who wants to share any lessons, any latest development, what they're working on, what they have achieved, what they have learned. We have for sure one webinar available, and then all these community calls, the 5 more community calls like this one that we have today. You can take that opportunity to present, to share with the community the work that you are doing. So feel free to reach out if you are interested to participate. And that kind of summarizes the regular update that we have with the ongoing activities. I think we're right on time for with the agenda. Before we pass it on to Wayne, I'd like to take a minute here to answer any questions anybody has about anything we discussed here. Okay, nothing. Before we move on, I just want to ask everybody about the elections, nominations and participation. All right. So we're coming now to the technical presentation. I would like to thank Wayne Henderson, who is the managing director of Marex, for participating in the VNV calls with Rodica and for kindly offering to give us a presentation today. You can see here, Marex is a 25-year-old company. It came out of, some unfortunate events in the North Sea, and it works in an area that is very critical, in the past and going forward, and that is accident prevention and verification and making sure we operate in a safe manner and accountable and traceable, etc. So this will never go out of fashion. It's a company headquartered in Aberdeen, but they have a global footprint, as you can see here. They will have a wide range of clients, and without me taking more time, I'd like to pass it on to Wayne to give us the presentation stamp. Wayne, the floor is yours.
Okay, thanks very much, Demetrius.
You want to become the presenter to share your slides?
Yeah, I'll share.
Let me stop sharing. We're seeing the notes.
Yeah. I'm just going to Here we go. Here we go. Okay, right. Good morning, good afternoon, everyone. Thanks for the invite, Dimitrios, and also for the introduction. I will go straight into the introduction. So the introduction is of STAMP, a methodology that maybe some of you are aware of. You may have heard of it. So what I'll present today is what STAMP is, how it could be utilized. I'll give a few examples of where it can be used, go through a step-by-step process, and really just give you an overall flavor of what STAMP is about. So STAMP is, as it stands for, a systematic theoretic accident model and processes. So you may already be familiar with other accident casualty models such as Swiss cheese, domino effect. So it's similar in the sense, but it's based on systems theory and systems engineering. So it looks at the system holistically. And it's a relatively new concept. It's been around for about 10 years or so. And the statement that we'll be familiar with, the whole is greater than the sum of the parts. So traditional methods that you'll be familiar with also, like sort of HAZOP, FMEA, which are very much analytical, decomposition, manage the complexity by breaking down the system into manageable chunks. These smaller, putting them back together, it does not necessarily reflect what is happening in the larger system. And that's what really STAMP brings to the table. And it's how to really look at complex systems and how they behave and look at the individual parts, but as a whole system. I'll come on to that just in a little bit more detail. Sorry, let me just make sure. Right. So I'm just going to give you an example here of an operation, let's say. So Mars polar lander. So during the descent to Mars, the legs were deployed at an altitude of 40 meters. The touchdown sensors on the legs sent a momentary signal. The software responded, as it was required to, by shutting down the descent engines. What then happened was the vehicle free fell and was destroyed upon hitting the surface at 50 miles per hour. None of these components failed as they were due to, as they were designed, and none of them failed, and they all performed exactly as they were designed. The difference was that there was a momentary signal that had an effect. So the point here is that had the system been looked as a whole, each of those independent components would have been considered and how they may have impacted the other parts of the operation. So hold that thought for now. You may be familiar with Nancy Levison, who is at the Institute of Massachusetts Technology, and she's the creator of STAMP. And her statement is that almost all software-related accidents can be traced back to flaws in the requirement specification. These problems can pass every component, every subsystem, simulation, every verification effort. But there was a need for a methodology that could systematically identify such accidents proactively. So two key words there, systematically and proactively. So looking at the system as a whole and at that earliest possible design stage, concept feasibility. Systems approach to safety engineering. So the STAMP model, treat accidents as a control problem as opposed to a failure problem. Accidents are more than a chain of events. They involve or involve complex dynamic processes. And we're looking to prevent accidents by enforcing constraints on component behavior and interaction. So again, looking at the whole. And STAMP captures many causes of accidents. So failure accidents, looks at the complex human interaction, software behavior, design errors, and the like. So that's the STAMP model. The STAMP model consists of two parts. So we have, I'm just going to introduce CAST here. So that's a causal analysis based on systems theory. So it's more for the incident investigation analysis. But what we're really looking at here is the STPA part, which is the systems theoretical process analysis. So that's more of the proactive hazard analysis and identification. And it's fair to say that from a DSATS point of view, that the STPA is the much more appropriate application than CAST. Okay, so we'll move on to the foundation. So basic theory control. So we have the controller, the process, the control actions, the control process, and then the feedback and that cycle. So really what we're looking at from STAMP is it provides another way to think about accidents, and that's what forms the foundation for STAMP. So being the foundation, we'll move on to follow that through. So we're managing complexity. So lessons from systems theory, the cognitive science, the human mind manages complexity through abstraction and hierarchy. What STAMP does, it uses a top-down process. So start at that higher abstract level, iterate to emphasize the approach on drilling down into more detail, and then build hierarchical models of the system. And I'll show that on further slides, what I mean by that. So how's it done? There's 4 steps to apply STAMP, or certainly the STPA part of STAMP. So first of all, we're going to define the process of analysis. So that could be system losses, the hazards, the constraints, whatever you feel is applicable to define the analysis and what you're looking to apply STAMP to. The model, the hierarchical control structure, so that will be developed. Then we'll go on to identify the unsafe control actions and identify the loss scenarios. So I'll go through each of these 4 steps in the following slides. So this is just purely an example, and those of you who have a Tesla, for example, may well relate to this. This is a study that was carried out, and I need to give reference to a student called Asim Abdul Akali, who used this as part of his thesis. If we look at the system here, where you have adaptive cruise control on a vehicle, it's fairly complex. But really the key message here is that through all the complexity and the control interactions, interfaces of what allows adaptive cruise control to operate, rather than looking at each of these individual components in their own right, we'll look at this as the whole system using STAMP as the methodology. So back to the steps. So defining the purpose. So the purposes can be, you're looking at an accident or a loss, you're looking at a hazard. So looking at an accident, an undesired or unplanned event that results in a loss, including could be the loss of life, could be injury, could be property damage, environmental, and so on. The hazard, a system state or set of conditions that are set to incur a worst case on the environment and how that may look. So that's the definition phase of the scope. So we'll look at that in a little bit more detail. So if we go back to the model of the cruise control, so the loss could be that the vehicle crashes with the vehicle in front because we've had a forward collision. The second part of the loss could be the vehicle behind crashes into the vehicle. And then the hazards could be very much that the vehicle has violated the safe distance that has been set up to maintain from the vehicle in front. And then the hazard also being the fact that no lights on the brakes were visible, so therefore the vehicle behind did not know that there was braking going on, and it continued to drive at speed and crash into the vehicle who has the cruise control. So breaking that out into the step 2. So what's that hierarchical control structure? So we can see there that we've got the various elements, so the brake control, the brake light, the operator being the human, the whole control process in the vehicle speed, and back into the sensors that ultimately allow the vehicle to maintain that distance and provide the indication from the vehicles around it of what is happening. So that would then be what would be developed. And again, this is going back to the system that you're looking to apply STAMP to. Step 3, we're then looking at what is the unsafe control actions. So we can see from that model that there was a need to provide a brake request, which didn't happen, a brake light for the rear, which didn't happen. The wheel speed did not slow down, it continued, and there was no means of the overall sensors around the vehicle. So look at that in just a little bit more detail from the uncontrolled action. The parts that become unsafe, really looking at the control actions of the source of the controller, whether the control action was provided or not provided, the controller command that was provided, it may have been missing. There could well be environmental conditions that we were talking about here. But again, this is how we then look at the system from a top down and structure in a way that we really started to understand this system and how we apply STAMP. So what we're really coming to is the identified safe actions in a means that we're really identifying each of those unsafe controls. So the brake command, the brake light, you'll see that we continue to make references to trace every single one of the unsafe actions, what may have been correct, how the vehicle performed, and really highlight these areas that need to be addressed that were unsafe control actions. And from step 3, we then move on to identifying each unsafe control action and then translate that into safety constraints. So for example, this is where you'd apply this particular outcome at step 3 into what would be that proactive design. So really starting to state that this is what you expect to have included in the design. So really get involved at the early possible stage to say, feasibility concept, this is what we want to have based on the assessment, the proactive assessment from STAMP that's been done so far. So for example, safety constraints, vehicle must illuminate the brake light to one vehicle at the rear. Brake light command must illuminate early within whatever number of seconds before stopping the vehicle. So being very specific when you're working with a design using STAMP as to what you feel, and from the analysis that's been done so far, that must be included in the design. Step 4 is really moving on to identifying the loss. So again, back to the model in a bit more detail that we're assessing here, and getting into process what was the incorrect piece of that, the control algorithms, feedback that may have been wrong. But again, it's a further level of analysis where you're identifying loss scenarios. And then taking that further, again, breaking it down to something that's a little bit more simple that then can be used moving forward. And what are these causal factors leading to, for example, the hazards that were identified early on. And then identifying what are these improvement measures that you're looking to have in place. So again, inputting this into the design at the earliest possible stage. I know that's a lot, and I know it can be very, very complex, but I'll again just address that at the end of the presentation. this is another example, even a larger complex system where we're looking at air traffic control. And we're not just looking at air traffic control in the tower, but we're looking at the flight crew. We're looking at the automation in the aircraft. So again, the point here is that STAMP is not just a matter of looking at the system, but how do you take that to levels that may have interaction with the system? So air traffic control related to the flight crew, related to the automation of the aircraft, and so on. So just an example of how it can be applied at various more holistic levels in an overall system. Again, just a little bit more detail about how that's broken out. And I'll explain as we go on why we break it out into this level. And this is really the reason why. In order to apply STAMP as a methodology, it's important that we have personnel involved in the project who have a technical understanding of the system that is being assessed. And the reason for that is, you'll see from the pie chart that 50% of the requirement of applying STAMP is the technical understanding of the system. Not applying STAMP, but if you can understand the system, you can then identify what you're looking to achieve from applying STAMP as a methodology. So we may need cross-discipline representation. 9 times out of 10, that is the case. But then where the STAMP knowledge comes in is good facilitators who understand STAMP and who understand human factors engineering principles, where they can lead the project team through the use of STAMP, but also having that technical input, of those individuals who clearly understand the system that's being assessed. I guess it's one of these analogies where, let's say, for example, you're decorating your house and you're painting a door, you're painting the wall or whatever, and the best preparation you make in terms of rubbing it down, the smoothest surface, well, of course, when you apply the paint, you're going to get the best finish possible. So it's that preparation up front of knowing the system in enough detail that you can apply STAMP much more effectively to get the results that you're looking for. So benefits over other methods and tools. It applies to both software and human, and they're given adequate consideration as being ultimately the controllers in a system. It enables the definition and really enforcing the safety constraints in a design. It could be particularly useful during, as I've mentioned on a few occasions, looking at the concept, that early stage and feasibility design validation. And and strangely enough, as much as it's come across in this presentation as being complex, it can actually take less time than a HAZUP or an FMEA. Purely because you're working from a top down. You're not looking at individual components and breaking them down and building them back up. It's that top down and then looking at a greater level of detail as you go through each stage, and it can actually result in being far more effective and efficient in terms of applying STAMP as a methodology and getting the results in terms of potential failures. How do you build that into the design so you're mitigating that moving forward? And I touched on this earlier, but it can be scaled up and scaled down. And where we found it particularly useful, if we're looking at a system that we do take in organizational levels, we do apply, where necessary and applicable, the regulatory implications, legal, any government interactions in relation to the system that is being assessed at any one time. So again, it's moving away from any isolation and evolving the application of STAMP to make sure you're covering as much of the holistic overall system and its interacting parts. And I guess just re-emphasizing where is the most effective means to apply STAMP is looking at this diagram where the cost to fix is much, much lower by applying STAMP and because it's a proactive methodology at the most early part as possible in a design. So if that can come in at the concept, then great. I appreciate that there'll be instances where there's existing plant, you're introducing a software, it may come in at the bolt-in stage, further up the curve. Plant's already been built, it's a modification to a plant, and it may be a little bit more costly. But the point is, as early as possible is the much more cost-effective means in terms of lower cost implications. You apply it later, it's going to cost that little bit more, but again, it can be applied throughout the life cycle, if you like, of a system. And we've had experience in applying it across both situations. But the early decisions certainly have the biggest impact, positive impact. And just to finish off, the applications, handbooks, a link to stamp related publications is in the link that I've attached there. I appreciate that was a bit of a run through. I'm open to take any questions at this stage. That is the end of the presentation.
Thank you very much, Wayne. I suggest if anyone has questions, please raise your hand, and then we go in order one by one. I have a couple of questions, Wayne, while we wait for more people to participate. So the first one is the overall stamp process still a very manual process, or are there any tools to help, let's say, avoid missing something, some software maybe that can help cover all the scenarios, all the different combinations, all the different paths of execution, let's say, because if we leave it down to people to try, what if this and this and this happens, it's going to be very tricky to cover all possibilities. What is the maturity, let's say, of the concept?
Well, I'm not aware of any software that's necessarily. We haven't used the software. We have much more dealt with this in a workshop environment by involving people with multidisciplines who understand the system.
Yeah.
And then facilitate it. So I guess if we look at HasOps, it's of a similar nature about how we would run a stamp application, and it's purely because rather than using a software, we want to have the interaction, we want to have the dialogue, we want to have the development of that more detailed approach in looking at the system from those who have the knowledge. And I think the other thing too, as you're making the changes and you're coming up with ideally an improved design, that you're getting the buy-in from the individuals as well. It's they're bought into the result. They feel they're part of the result, and any future change is then much easier to implement than it would be if you've said, okay, here's the software, here's how we've done, and here's the result. Right, let's get on. So it's more of we found the value being much more interactive in its approach.
Yeah, okay. Thank you, Wayne. There is a question from Brian Atchison. What other industries use this tool? What complex multi-system environments has this been applied to?
From our point of view?
Yeah, I mean, of the overall stamp or the methodology.
Okay, well,
you mentioned, the lander, the lunar lander. You mentioned the vehicle. Do you have any specific examples that people use this methodology?
Yeah, so I'll answer that in two particular ways. One, it has very much come from the automotive industry. Where we see cars improve in terms of the control systems, their operation, the sensors, the complexity. I'm sure we could all relate to it, that we used to take a car to the garage, it was very much mechanical. We take a car to the garage now, it's very much computer. Mechanics are different in garages than they ever were before. So it's much more a plug-in computer and you're looking at the diagnostics. So it's very much been driven from the evolution of the improvement in cars mainly, and certainly around aircraft development. And where we have, in addition, applied it to what is our core business, where we've worked with new vessel owners, and particularly in the renewable sector, where they've been bringing new design vessels to what is larger wind turbines that they've never installed before, at depths that they've never experienced before, and wave heights they've never experienced before, crane lifts and weight and spans and so on, equipment of sizes that have never been experienced before. We've applied STAMP at the very earliest possible stage of the design, so that we can iron out, or at least identify, any potential hazards and safety issues that may arise, but at least are known.
Okay. Thank you, Wayne. The next hand up was Varun. I think he may have a comment. Go ahead, Varun.
Yes. Well, good morning or good afternoon, depending on where you are. Apologies for joining a bit later than I was meant to, but I was traveling. I believe. Well, just to introduce myself, I work for Maddox. So Wayne is my boss, and I'm the human factors person who tends to do some of these studies. STAMP is one of the tools within human factors. We've used quite a few other tools, but I had my hand up really just to say that I'm now here. Wayne, just in case you needed some support, in terms of the questions that have been asked, if there's anything that I could share. And just going back to the first question, Dimitrios, I believe, about software. Well, we haven't used it, but yes, people who are associated with it. So it's not from the creators of the STAMP tool, but others have tried their hand at automating this process. So there are some softwares out there. So if you follow that link on the screen, it takes you to the home page of the MIT website who created this STAMP methodology. But within there, you would find a tab for STAMP tools. And if you go in there, it's actually quite open source, free to download. It's something for you to that you could look into. But of course, the understanding of STAMP needs to come first, and then the use of these tools to automate the process. But like any software, I believe, like I said, having that fundamental knowledge and awareness of how to be able to apply is certainly essential. But yes, there are I think at least a couple of tools that try and automate this process to help, because like Wayne said, for complex systems, when there's multiple interactions, there's so many different interactions happening. There could be hundreds of unsafe control actions, like Wayne would have explained. So there are tools that could, now to be honest, it's not something that we have tried. Not to say we are not open to it, but I believe it's certainly worthwhile exploring.
Okay.
So
very good.
Yeah, maybe some of you could beat us to it, but we will make a point of looking at how effectively these tools work. Yeah.
Okay, thank you, Varun. I think the next hand up was Fred. Yeah.
No, just the second question. I think aviation is one of the other primary industries where this has been extensively applied, STAMP. Not by us, but as the tool as such. Yeah, aviation is one of the key fields that has benefited, along with nuclear as well. Yeah.
Okay, very good. Fred?
Yeah, Wayne, thank you. You brought something new to mind that maybe you and Radhika need to look at in the future. Most of the projects that we've been doing are focused for specific functions, specific tasks of a certain scale, and yet we're building a system that we can scale up. So when I think about the early days of robotics, the teams learned that how they were trying to control their rig, but the systems didn't have the right response time. And then as they got more complex, then maybe that they got it fixed. And then as the system got more complex, again, they didn't have the right response time. And so we build a system that's going to do the 4 or 5 tasks of ROP optimization and tag and bottom and the things that we're talking about. And then we start adding Brian's stuff on here for well control and maybe some more managed pressure drilling systems. And then later we invent another system that we add to it, and we might be running into some time constraints as we expand the system. So I think that somewhere in the validation process, we need to be looking at that, at the response times, or some of the things that take place that I can't think of yet that really occur when you have more and more players plugged into the system.
Yeah. And
thanks for opening the eyes there.
And Fred, could you just be a little bit more specific on the response time that you're referring to there? What issues specifically have you seen?
No, I haven't.
Oh, you haven't?
What they had in the Drillbotics stuff was they didn't have a fast enough controller, and they had instability and they couldn't operate. But what happened was when they started going into the directional world, when they started getting more sensors from other places, then they saw more difficulty. And so in DWIS and in the drilling operations, we may have an equipment manufacturer and 1 or 2 service companies initially, but later we may have 5 or 6 service companies. We may have downhole tools, surface tools. We may have some kind of interfaces with the remote centers. We don't know where these delays are going to come from. So from a true systems approach, we have to look at the how scalable will the big system be?
Yeah, and I think it'd be worth to get Vern's input on this as well. But I would certainly say that let's say, for example, the system that you're talking about has an input from one supplier at one point in time, and then in future there's another input and another supplier, another piece of equipment, and so on, and the system grows. I think it's always recommended that, and STAMP could be one of those tools and methodologies to apply, but you'd look to take the holistic view at each time there was a new introduction of a piece of equipment, a control, a software, or whatever into the system. So regardless of what was input at some point in the past, you would always consider that with the newer input at that future time.
Yeah.
And at any one time, you're looking at the holistic system.
Right.
And assessing the implication of whatever is added against what exists.
Yeah, and it may be that you bring in a different company who has different equipment that has different response times. So what you presented today made me look at the problem in a broader view. Thank you.
Okay, thank you, Fred. The next question is from the chat from Maury. He said, in your experience, what is the relative maturity of these within drilling? One, from a drilling rig perspective, and then 2, from the extended platform with multiple connected vendor systems. Do you know if any big offshore platforms, etc., have used this methodology, Wayne, offshore or even on land, when they build their integrated, let's say, rig systems?
Yeah, I think that's a great question, and I guess I'd like to say yes, but I would say that STAMP is still evolving as a methodology.
Yeah,
we are talking about it more. Vern's probably better to answer this question in terms of what he sees as the application. But I don't think it's as widely used, and certainly when we've as we'd like it to be, and certainly when we've had the conversations, it is a newer process to people.
Okay.
But I think there is a great opportunity to have it much more, let's say, understood, applied, tried, and and tested that it could evolve into being a much more usable methodology. Varun.
Okay.
Yes, I would second that. Just to say, there is perhaps at the beginning of the presentation, there might have been an element that Wayne showed where there's two primary tools within the STAMP methodology. Well, STAMP methodology. One is the STPA, which is a hazard analysis done proactively, and the other one is a reactive, which is a causal analysis, which is more of an incident investigation. Now, I'm aware there's been a couple of incident investigations that's been applied to, say, for example, Macondo, just to do a reactive analysis using the STAMP method. So a cast analysis has been done, but using this as a proactive tool, we're not aware of ourselves of work that has been done on a considerable scale proactively as a hazard
Okay.
analysis so far.
I thought I see Brian has his hand up, and before that Pradeep, but now I'm not sure if Pradeep is still here or no. Brian, do you have another question?
No, thank you. My question was already answered. Thank you.
Okay. I have another follow-up question, Wayne. Do any of the certifying bodies, DNV, etc., are they looking into using this tool for their reviews and their certifications?
I am not 100% sure just how much of a focus STAMP is for them. We haven't seen it come across any involvement that we've had with them. Van, have you got any greater insight on that?
I'm afraid not. Again, it would be fair to say STAMP, although it's been around for 10 years, it's only sort of gaining traction more recently. It's been widely used and researched in the academia, if you may. But in terms of industrial applications, it's been more yes in the States, United States, because where it's originated, and the aviation industry, a lot of it has been in use in practical and industrial applications. But as far as we are aware, the class again, I wouldn't say I would know for sure, but as far as we are, we are aware it hasn't really reached that phase of how, for example, HAZOPs or FMEAs are acknowledged by the class society. We aren't entirely certain whether STAMP has reached that stage yet.
Okay, very good. And I just try to put in the chat the link that you have there on the slide, so people can copy it and visit later at their convenience if they're interested. So, do we have any other questions before we go back to wrap up the call? Any questions, any comments from anybody? Wayne, thank you very much. Very interesting presentation.
Thanks, Demetrios.
All right, so let me go then back to the last couple of slides from my deck. Let's see, I think we're here. And so we are finished a little bit early compared to the original agenda, but nevertheless, I think it was time very well spent. So, as I mentioned earlier, if you would like to share any success stories or any latest developments in the work that we are doing, feel free to reach out. We have a few opportunities, through the webinars or these community calls. Also, I would like we always have a standing invitation for people to engage and participate in the ongoing activities, whether it's as a judge in Drillbotics or as a participant in DWIS or DNV or any of the other ones. Always new people and new ideas are welcome. remember, the mission of the section, of the technical section, is to act as a catalyst to promote this dialogue within the industry. And the next call is going to be on the 14th. It's the day before the webinar, actually, the week after the drilling conference. That's going to be a busy couple of weeks in there. So March 14, 8:30 in the morning. That's a Thursday. The webinar will be next day on a Friday. The invitation will come a week or so before the call. We're delaying it on purpose to have the latest membership list from SPE. And that's pretty much it for today's call. Thank you for dialing in to everyone. If anyone has any comments, questions, etc., feel free to reach out. Thanks again, and have a good day. Bye.
Thank you. Goodbye.